Hello class, thank you for tuning in to the 7.7 Geometric Sequences as Exponential Functions video. Before we get started with the geometric sequences, I want you to go ahead and pause the video and complete the first 5 review problems. When you get back, we'll talk about some new vocabulary terms. Our first vocab term is geometric sequence, which is a sequence in which each term after the first is found by multiplying the previous term by a constant r, which is called the common ratio. So the common ratio is the ratio of successive terms of a geometric sequence. So let's put these two new terms into practice. For our first question, we are asked to determine whether the sequence is arithmetic, geometric, or neither. As you guys talked about before in this semester, an arithmetic sequence is whenever we have a common difference. So whenever we're adding or we're subtracting a constant by the first term. Geometric is whenever we're going to multiply by a common ratio. So if we're not multiplying or adding or subtracting, then our answer is going to be neither. So let's take a look at our first term in this example. First term is 0. And our second term is 8. So the first question we're going to ask is, what can we do to 0 in order to get to our second term, 8? Well, we know that this can't be a geometric sequence because we can't multiply 0 by anything to get number 8. So in order for us to get from 0 to 8, we're going to have to add 8 to 0. So 0 plus 8 is obviously going to give us 8, and that's our second term. So let's see if this is common throughout the rest of the terms. What if we added 8 to our second term and see if we would get our third term of 16. So if we have 8 and we add 8 more, 8 plus 8 is going to give us 16, so our third term works as well. Let's see if it works for the rest of them. 16 plus 8 is going to give us 24, so the next term works, and then 24 plus 8 is going to give us 36. So the answer to this question is going to be that it's an arithmetic sequence because we're simply adding 8 over and over again. So we have a common difference of 8. So let's look at our next example. For our next example, they ask us to determine whether the sequence, again, is arithmetic, geometric, or neither. So let's first look and see if it's geometric or if it's arithmetic. And we can do that by seeing if there's a common difference between each term. So what's the difference between the first term, 64, and the next term, 48? We subtract those and we get a difference of 16. Okay, so let's see if there's the same difference between the second term and the third term. So we're going to subtract the second term minus the third term, and that difference is going to be 12. 16 and 12 are not the same number, so there's not a common difference. That means it is not going to be arithmetic. So we can erase that, and we can test to see if it's geometric now. So geometric is when we are multiplying by a common ratio. So a trick for finding the common ratio is if we take the second term and put it on top of our first term. So we'll do 48 over 64. If we reduce that, we will get a ratio of 3/4. Okay, so that's the ratio from the first term to the second term. What is the ratio from the second term to the third term? Well, if we take the third term and put it on top of the second term, get 36 over 48. If we can divide each of those by 12, and we can reduce that to 3/4 again. Okay, so we have 3/4. Let's see if it's the same between our last two terms, 36 and 27. So we take 27, put it on top of 36. If we divide each of those by 9, we're going to get 3 over 4. So what do we see here? We have a common ratio between each of the terms. What is our common ratio? Our common ratio is 3/4. So it is geometric sequence. Okay, I want you guys to go ahead and use the same methods and see if you can do number 3 on your own, and let me know if it's geometric, arithmetic, or neither. And we'll take a look at example number 4. So example 4, they ask us to determine if it's arithmetic, geometric, or neither. So let's first see if it's arithmetic. So if it's arithmetic, then it has to have a common difference between each term. So what's the difference between the first two terms? 2 minus 1 is 1. What's the common difference between the second and third term? 3 minus 2 is 1. What's the difference between the third and fourth term? 4 minus 3 is 1. So it looks promising so far until we get to the next one. The fourth and fifth term, 14 minus 4 is not 1. That's 10, right? So we don't have a common difference, which means this cannot be arithmetic. So let's see if it's geometric. If it's geometric, then it has a common ratio, right? So we can take our second term, put it on top of our first term, like we did in example 2. So we've got 2 over 1 gives us a ratio of 2 over 1, which is 2. How about of our next term? Our third term, put that on top of our second term, we get a ratio of 3 over 2. That can't be reduced any further, so it's going to stay 3 over 2. And we have two different ratios between those two terms. So it's not a common ratio, which means it cannot be geometric, which means this is going to be neither. So for our next example, they tell us that it's a geometric sequence, and they want us to find the next 3 terms. So before we can find the next 3 terms, we need to do our first step, which is to find the common ratio. So how did we find the common ratio before? We took our second term, put it on top of our first term. So negative 8 over 1 is negative 8. So we know our common ratio is going to be negative 8, and we can test it to make sure that this is geometric if we want to. So if we took 64 and put it on top of negative 8, sorry, we're going to get negative 8. So that's just more evidence that our common ratio is negative 8. So now we know the common ratio. All we have to do is multiply to find the next 3 terms. So if we're ending at negative 512, we're just going to multiply negative 512 by negative 8 to get our next answer. And so that answer is 4,096. So that is our 5th term. Now we need to find the 6th and 7th. To find the next term, we're going to multiply 4,096 times our common ratio of negative 8, and we're going to get negative 32,768. So they asked for 3 terms. Now we're going to multiply this term by negative 8 as well to get our last term, which is going to be 262,144. So our next 3 terms are these 3 numbers. So you guys can go ahead and do number 6 and number 7 on your own. I'm sorry, 6, 7, and 8. You can do each of those on your own. And we'll take a look at our next example, our next key concept, where we'll introduce a formula. So now we're going to use this formula right here to find out what the equation is for each geometric sequence. So for this formula, we have a with the sub 1, which is going to be the first term. So that's what the 1 represents. A sub 1 is the first term. So that means if we had a sub 2, that's going to be the second term. A sub 3 is going to be the third term, A sub 4 is going to be the fourth term. Okay, so that's what the A sub 1 means. The common ratio is going to be R. And then we can use this to find any term in the sequence that we want to find. So let's take a look at our first example. They've given us a geometric sequence, and they want us to write the equation for the sequence. In order to find the equation, we need to know two things. We need to know A sub 1, which is the first term. For this example, the first term is 1. So we have that. We also need to know the common ratio, which is R. So let's do what we did previously to find what the common ratio is. We're going to take the second term, put it on top of the first. We got negative 2 over 1. Going to give us negative 2. And just to check and make sure that's correct, we're going to take the third term and put it on top of the second. 4 over negative 2. We can reduce that to negative 2. So the common ratio is going to be negative 2. And then we can plug those into our equation. So a to the n, whenever we say n, we're just saying we can fill in whatever number we want for that. We can find that term. So a to the n equals the first term, which is 1, times the common ratio, negative 2, to the n minus 1. And I'll talk more about what the n means in our next example. So, now they want us to find the 12th term of the sequence. As you can see, it's the same sequence that we talked about before. So we know the formula for this. A to the n equals 1 times negative 2 to the n minus 1. So if we want to find the 12th term, that means we want to find a to the 12, a sub 12. So we're going to substitute a sub 12 in for this. We have 1, we're using the same formula. What is n? Well, right here, n is 12. So we're going to substitute 12 in for n. 12 minus 1. And then we can find out what the 12th term is by simplifying this. So we have 1 times negative 2 to the 11th power, because 12 minus 1 is 11. And then we are going to only apply the exponent to what's in parentheses. So we're going to have a sub 12 is 1 times negative 2 to the 11th is going to be negative 2048. And so negative 2048 times 1 is negative 2048. So our final answer is negative 2048. That is our 12th term. So you guys can go ahead and do number 3 on your own, and we can answer any questions about that in class.